All right. So we've got a rational function here. Is it in the form we have been using for the last 2 days to tell all of our things? No. Because we want it to be the polynomial over polynomial thing, where I have matching top and bottom, or a single fraction where we have, ideally, things matching top and bottom. So what do I need to do here to be able to make this be something we can work with? Common denominator. So what do I need to multiply my 2 by? X minus 3 over x minus 3. So my function's going to be having a denominator of x minus 3. We have x minus 2 times x minus 3. Like this. And then we need to simplify it. What do we get when we simplify this? Yep, so we have x minus 2x plus 6. So x minus 2x minus 1x plus 6 over x minus 3. Because we just simplified it here. And you don't have to put the 1 there. Minus x plus 6 over x minus 3. Questions on that bit? Okay, just checking in. Because I know we're Friday, day after Halloween, and just after a quiz brain, so we're a little gooey. So, is there anything that can simplify out top and bottom factored form style? It's not. They're both linear pieces, so if everything canceled out, anything canceled out, we wind up at 0. So we do not have any discontinuities. We have no holes. It's important that we check, but this one does not have any discontinuities. Our x-intercepts, how do we find the x-intercept? Yeah. It's when y is 0. What that really is, it's our solutions to the numerator. It's when the numerator equals 0. So when minus x plus 6 equals 0. When does minus x plus 6 equal 0? At 6. So x equals 6 is our x-intercept, which is the point 6, 0. So we are going to have a point right there. You don't have to put things on the graph as you find them. You can, but you don't have to. How do we get our y-intercept? Substitute in 0 for x. Sub in 0 for x. So what is our y-intercept? Y equals what? Yeah, because we have 0 plus 6 over 0 minus 3. So 6 over negative 3, that's negative 2. So our y-intercept is at the point 0, negative 2. Boop. So it's going to be there. Our vertical asymptote color. There we go. Our vertical asymptote, where do we get that? How did we find that? It's when the denominator equals 0. When our denominator equals 0. So our denominator equals 0 when x equals 3. So our vertical asymptote is going to happen at 3. So when we draw that on the graph, that's when we get our dotted line. It's going to look, wow, that's fresh. There we go. it's kind of like that. There we go. Our horizontal asymptote, or our end behavior asymptote, that's when we're thinking about our, is it the numerator bigger, the denominator bigger, or do they have the same degree? So do we have a bigger degree in the numerator, bigger degree in the denominator, or are they the same degree? Same degree. If they are the same degree, what do we look at? The leading coefficients. So it's the ratio of the leading coefficients. So our horizontal asymptote is going to be when y equals, what's our leading coefficient of the numerator? -1. And what's the leading coefficient of the denominator? 1. So our horizontal, horizontal asymptote is at y equals -1. So our horizontal asymptote it's like it's just piecing together all the things we've done over the last 2 days. Looks like that. From the information that we have, can we tell where our curves are going to be? It's going to go through the points we've plotted, and it approaches our asymptotes. So can we figure out where things are going? Yeah. So I know it's going to go from this point towards my asymptote, and it's going to go from this point towards this asymptote, like that. From my x-intercept, it's going to approach the asymptote, or the horizontal asymptote, and from my x-intercept, it's also going to approach our vertical asymptote, which I was like, we can. But sometimes, I just think it's easier sometimes to state our end behaviors once we have a picture. I don't know that we're asked to, let me check and see what we're asked to put on the picture. So, we're not actually asked to list out the end behaviors or anything like that on the graphs. So you can, but you don't have to. I was just double checking the instructions. The end behavior is mostly so we could figure out what's happening here. But that's how we make these graphs, guys. This one's done. So it's putting together the things we've done in the last couple of days. When we are graphing these, I do need you to actually graph the asymptotes. Don't leave them off. Put the lines on there. Plot the points. Don't just give me wishes of curves. Show me the things. I need to see the asymptotes. I need to see your points. Make things clear. Okay. Let's do another one. Okay. This will be our last one. We'll just do these two. Okay. So this one's a little bigger. I've got x squared minus 4 over x squared minus 2x minus 8. What should we do first? Let's factor everybody. A lot of the things we need to know them in factored form anyway. So if we have something that is quadratic, it is a good idea to always start out by trying to factor stuff. So what is my numerator going to factor to? X plus 2, x minus 2. There we go. And what was it our denominator is going to simplify down to be? X minus 4 and x plus 2. Okay, so the factoring part is really important. What do we notice here? We are going to have a discontinuity here. We're going to have a whole because my x plus 2's cancel out. So where is our discontinuity going to be located? At -2. But is that enough information to, hello, delay, thank you. Is that enough information to be able to graph my hole? The hole. So our remaining bit, what we have left over after we simplified out that factored form, we've got our leftovers of x minus 2 over x minus 4. How do I find the y value of the point for that discontinuity? Substitute in our -2 into that leftover bit. So to find the y value for our discontinuity, our y is going to be at our -2 minus 2 and our -2 minus 4. Which, when we simplify this, we're going to have our -4 over -6. So the y value is going to be 2/3. So our discontinuity is at the point -2 2/3, which is kind of icky, but we can do that. So when we are graphing discontinuities, -2 and 2/3, that's where we're going to have an open circle. We're going to have a hole. And we're just kind of eyeballing it. It's somewhere between our 0 and 1, right on our -2. So the discontinuities make things a little different there, but everything else is the same. So where are we going to have an x-intercept? 2, 0. It's our solution for our numerator. So 2, 0, we have an x-intercept. Where are we going to have a y-intercept? That's when we are substituting in 0 for x. So our y equals 0 minus 2, 0 minus 4. So our y is -2 over -4, which is positive 1/2. So our y-intercept, that's at 0, 1/2. So 0, 1/2 is kind of there-ish. Let's find our asymptotes. Where are we going to find our vertical asymptote? It's the zeros of our denominator, so that's going to be our x equals 4. So our vertical asymptote is going to be right here. Where are we going to get our horizontal asymptote? What do we have? Say it louder, I can't hear you. 1, yeah. I just kept hearing y equals from. I'm old and it's a Friday and we're tired and I get that. So y equals 1, our asymptote's right here. What's up? Ooh, be louder, I can't hear you. That's when we're looking at our ratio of our leading coefficients. 1/1. So our asymptote, that's the 1/1. Or over here, 1/1. It's the same thing. All right. So I have enough information for part of my graph. I can see this side real easy. Looks like this. And it gets real close to my asymptote. Can we tell what's happening on the right side of the graph yet? So what could we do to figure out what's happening over there? Sub in a point. If we don't have any points on one side of an asymptote, pick a point, pick a couple of points if you really feel like it, and substitute something in. So since I don't know what's happening over there on the right-hand side, I'm going to pick something to substitute in. What x value on the right-hand side of the graph, right of our asymptote, do we want to use to try and figure out what's happening over there? I would now recommend 17 as it's not actually on our graph. You could use, I was like, you could use 6, you could use 5, you could use 9, you could use 10. Like, you can use anything over there. I heard 6 first, so we're going to do our f of 6. You can use the original function. You can use our remainder function. It does not matter which one. Honestly, the remainder is probably going to be easier. So we have 6 minus 2 over 6 minus 4. Oh, I've now heard 2 different answers here, guys. 6 minus 2 gives us 4. 6 minus 4 gives us 2, so it should be 2. So we have 6, 2. And now I can see where that is relative to my asymptotes. We can get our shape going up. So it's going to look like that. Okay. On Monday, we're going to do a bunch more graphs. But I just wanted us to see what those look like. I'm going to put up the announcement page that has the homework questions. Also, as a word to the wise, if you don't show work on the homework, I'm going to stop posting the answers. I have a lot of people that are just giving me question 1, answer. Question 2, answer. Like on the next line, we're not doing any work. You're just copying things down. Do the work.